Hi guys, welcome back to section 3.3, video 2. See, I believe we got through problem 2, and we're now on example number 3. So these are all what's called common log. Common log is log base 10. Since we're a base 10 society, we have lots of examples for common log. So we don't want to write the 10 every time. So if you see a log without a number underneath it, so since there's no number down here, it's assumed that it is base 10 and it's called common log. So this guy is really log base 10 of 0.001, which is 10 to the negative 3. And since our bases match, this is equal to negative 3. For this one here, it's 10 to the log base 10 of 5, so it's just equal to 5. This is log base 10 of 26, and I cannot write 10 or 26 as a 10 to any exponent without using a calculator. So this one you might put notes in your start by it saying calculator. The only way you can do this one is with a calculator, and this would be 1.42. For D, I've got log of negative 5. Keep in mind, if you think back to the graph of the log of negative 5, it looked just something like this, right? Where we had it going down to the asymptote here. So did I have anything happening at negative 5? No. So anytime you get a log of a negative number, it's going to be no real solution because you can't evaluate that guy. You might also see it as undefined. And that's because the domain is only positive numbers. All right. Log of 10,000 is the same thing as log of 10 to the 4th. Since my bases match, this is just equal to the exponent. Same thing here, bases match, so it's equal to the argument, which is 3. This one I cannot write as a base 10 within a calculator, so plugging that guy into a calculator, I get negative 1.09. And then log of negative 0 is the same thing as log of 0. And we have an asymptote at 0, so this one is also no real solution or undefined. All right. Moving on to example 4. Same really as example 3, except for now we're talking about log base E. So log base E is what this ln is, and that stands for natural log. So it's the same thing as log base e of e to the 0.73. Since my bases match, it's equal to the exponent. E to the ln of 6 is just going to be 6. The bases match, so it's just equal to the argument. I cannot have the natural log of a negative number, so this one's no real solution. And natural log of 4 is just a matter of putting that guy into a calculator, and the calculator will tell you that's negative 2.20. All right, for the U-tries, natural log of 32, again, that's a calculator question, that's 3.47. If my bases match, it's equal to the argument. This is the same thing as natural log of e to the negative 3. Remember, if the exponent is in the denominator, I can put it to the numerator by making the exponent negative. So this guy is just negative 3. Negative natural log of 9. Before you say, hey, that's no solution, this is not the same thing as natural log of negative 9. This guy here is no solution. Natural log of negative 9 is just saying take that natural log graph and reflect it across the axis, x-axis, so it's going to look something like that. So that's just a matter of plugging this guy into the calculator, and the calculator will spit out negative 2.20. All right, and that leads us up to our, nope, we still have several examples. So example 5 is our properties of logs. And I'm actually going to do that on the next video. We'll actually start getting into the properties of logs.